Find the number of non-congruent right-angled triangles such that the length of all their sides are integers and that the hypotenuse has a length of 65. So let's draw our triangle. It is like this. This one side is A, one side is B, and hypotenuse is 65 because the problem says 65. Now, what theorem should we use here? Pythagorean theorem, okay, or Pythagoras theorem. If we use that here, a squared plus b squared equal to not 65, 65 squared. Look, one way is to calculate 65 squared, one way is to consider remainders when divided by 4, 3, but one way is to consider, for example, b without loss of its generality. Let's see, the problem says what? Find the number of non-congruent. So if you switch a and b, the triangle will be congruent. For example, if a is 1b 4 or 4 1, they are same. So we can say without loss of generality, suppose that a is less than or equal b. So the greatest b is, can b be 65? No, because then what we have a squared plus 65 squared equal to 65 squared, and then a squared 0, a 0. Contradiction. Can a be negative, b be greater than 65? Then a squared will be negative. So the greatest b is what? The greatest b is 64. So let's consider this a squared plus 64 squared equal to 65 squared. Then a squared equal to 65 squared minus 64 squared. And we want to use this identity, that x squared minus y squared equal to x minus y times x plus y. So if we use that here, it will be 65 minus 64 times 65 plus 64. It will be 1 times 129. 129 is not perfect square because 11 squared is 121, 12 squared 144. So this case is bad. If b equal to 63, let's check this case. A squared plus 63 squared equal to 65 squared. Then a squared equal to 65 squared minus 63 squared. Then it will be 65 minus 63 times 65 plus 63. And it will be 2 times 128. As you can see, it's 256, which is 16 squared. So we found one good answer. Here, for our A is what? In this case, A is 16, B is 63. So it is first answer. Now, if we check next one, if B equal to 62, look, if we do the same thing, let's write here, and after that we will find the pattern. A squared plus 62 squared equal to 65 squared, then a squared equal to 65 squared minus 62 squared. So it will be 65 minus 62 times 65 plus 62. And it will be what? It will be 3 times 127. 3 we have here, 127 is not multiple of 3. So then the power of 3 is 1, so it is not perfect square. So let's check something. 1, 129, 2, 128, 3, 127. The next one, if b is 61, 1, 2, 3. The next one, if you write a squared, will be 4 times 129, 128, 127, decreased by 1. So 126. Is it perfect square? No, because 126. Look, when it is 4, it is perfect square. This one should be perfect square, but 126 is not perfect square. If b equal to 60, a squared equal to. We should continue up to the case that b still should be less than, greater than, equal a. So the next one, 5 times 125, that's good because it's 625 and it is 5 raised to 4 or 25 squared. So another answer will be b equal to 60 and a equal to 25. So second answer. Now let's check b equal to 59. A squared equal to 6 times 124. 6 is multiple of 3, but 1 to 4 is not multiple of 3, so the power of 3 here is 1, is bad. The next one you can say it's 7 times 1 to 3. 1 to 3 is not multiple of 7. The next one is 8 times 1 to 2. Okay, 58, 57. Now, if you consider that 8, it will be 8 times 2 times 61. 8 times 2 is perfect square, 61 should be perfect square, which is not. Next one, 9 times 1 to 1. Again, it's good, because it will be 3 times 11 squared, which is 33 squared. So in this, B will be 59, 58, 57, 56, okay? B will be 56 and A will be 33. It is our third answer. Now let's check next case. 10 times 120. It will be 10 squared, 100 times 12. 12 is not perfect square, it's not good. 11 times 119. Is it good or not? 119 is not multiple of 11. 12 times 118. 1 here is multiple of 3. It's not multiple of 3. The power of 3 is 113 times 117. 117 is it multiple of 13? Yes. So it's 13 times 13 times 9. Okay, it's again good. 13 times 3 squared, which is 39 squared. So A is 39 here. So if you check the case, 56, 55, 54, 53, 52. And B is 52, A is 39. Still B is greater than A. Let's continue. 13, the next one, 14 times 116. Here it's multiple of 7, 116, 70, 30, 46. It's not multiple of 7. Next one, 15 times 115. So it's multiple of 3, it's not multiple of 3. 16 times 114. 16 is perfect square, 114 is not perfect square. 17 times 113. 17 is 17 multiple of, well, it's 113 multiple of 17. Let's check. 8. 8 times 7, 56, 136, no, 7, no, 6, no. So it's not multiple of 17, so it's not perfect square. Next one, 18 times 112. So it will be 9 times 2. 112 is 2 times 56, okay? Let's check to make sure. 56, yes. So as you can see, 56 is multiple of 7. Yeah, so the power of 7 is 1. It's bad. So if we continue 19 times 111, if we check 5 times this is 95, 6 times this is 104, it's not multiple of 19. Next one, 20 times 110, which is 2 times 11 times 100, the power of 11 is 1. It's bad. 21 times 109. This one also is bad. The power of 3 is what? 1. 22 times 108. The power of 11 is 1 because 108 is not multiple of 11. And you can continue. Now I want to say that here B will be less than A. Why? Because for example, for next case, A squared, if A squared, be 23 times. Sorry, 20, yes, 23 times 107, okay? Let's see, B will be what? 52, 50 here, 52, 51, 50, 49, 48, 47, 46, 45, 44, 43, 42. As you can see, it is 65 minus 43 is 65 plus 42. 65 minus 42. Now, A will be what? We know that A should be less than or equal B, so it should be less than or equal 42 squared. So let's see, is it correct or not? If we calculate this part, 23 times 100, okay, 23 times 107, 3 times 7, 21, 3 times 0, 2, 3, 2 times 7, 14, 1, 2. So 1642. So this part is 2461. 42 squared, 42, 42. It's 84, 4 times 2, 8, 16. Will be 4671. So it's 1764, which is right? So after here, or from some part here, A will be greater than B. What we said without loss of generality, suppose that B is greater than equal A. So let's see how many congruent and non-congruent triangles are there. 1, 2, 3, 4. So we found 4 non-congruent triangles. If you have questions, send message to my WhatsApp number and please don't forget to subscribe, turn on the bell and like the video. Thanks. Bye.